All right, this is lesson 1.3, and it's not really from the book from 1.3 though. And we're going to be looking at the following learning targets. Being able to solve absolute value equations, being able to solve and graph absolute value inequalities, so it'll still build on the skills that we worked on the other days, and being able to write and solve an absolute value equation. So first off, what is the distance from point A? What is the distance point A is located from 0? 5. You can see it's 5. Even though it's at -5, it's 5 units away. What is the distance point B is located? 5. It doesn't matter the direction. Distance is always positive. Particularly in our geometry class, we're going to have distance be positive. Now, there are certain cases when you get into higher levels of mathematics and physics where you can have it negative, indicating that it's going the opposite direction. But when we talk about the distance itself, the distance is always positive. Absolute value is the distance from 0, the distance of a number from 0 or an expression. And remember that it is always positive. Doesn't matter whether the number was a negative integer, like -5, it's still 5 units from 0. So if that's the case, if the absolute value of x is d, then what would x possibly be? X could be what? It could be a positive d, or it could be the opposite of d. And I say the opposite because I don't know if it's negative or positive, okay? Because maybe d was negative. Although I think it's got to be positive in this case. So it could have been positive or negative to begin with. So as we look at absolute value equations, we're going to look at some of them in particular. Absolute value of x is 7. So what does x have to be? 7 or -7. It could be either one. What's happening is the distance that this number is from 0 is +7. The distance this number is from 0 is +7. What about 1/3? Absolute value of x is 1/3. Then x is either 1/3 or x is -1/3. What about the next one? The absolute value of x is -4. We want to be careful here. What is absolute value telling us again? It's telling us the what? Distance from 0, and distance is always positive. So the distance is -4? Not possible, right? So this is no solution. Distance from 0 can't be negative. Now, you're going to have some equations that you're going to look at and go, oh, that can't work. But notice that it's when we have the absolute value by itself. If you have the absolute value symbol by itself, if there's nothing else around it, no multiplication or division or addition or subtraction on outside of it, that's when you can say, oh, the absolute value can't be negative, so that is no solution. All right, we're going to take a look at this problem right here, number 5. Number 5, I'm going to solve, and here's where people get confused. They're going, oh, Mr. Ritter told me the first step is to always distribute. Are those parentheses? No. This is like its own variable. This is like its own variable. Our job is to get the absolute value by itself. Okay, we have to get the absolute value by itself. It's like its own variable, so we have to undo all the operations around it. Now, some of you might have wanted to distribute. Why? What operation is between the -2 and the absolute value symbol? Multiplication. And then there's an addition here, right? So we have to get rid of addition first. This is like treating this as 5 minus 2x equals 1. I'm going to subtract 5 from both sides. This will give me negative 2 times the absolute value of x plus 1 equals negative 4. And here's where I have people get confused, like, oh, it's negative, it's no solution. But the absolute value is not by itself yet. Okay? How do I get the absolute value to be by itself? What am I going to do? Divide by negative 2. Since it's multiplied, I'm going to divide by negative 2 on both sides. So again, the absolute value is like a fraction, is like its own number. There's a multiplication between it and the negative 2. The negative 2's cancel. We now have the absolute value of x plus 1 equals 2. We're going to solve this in just a second. But first, if this was just x, what number would I put in the absolute value and still get 2? I could put in 2 or negative 2. So when you get to this point, so your first step is to get x by itself. Your second step is once it is by itself, you have to split it into 2 equations. One equal to the positive value and one equal to the negative value. So for this one, our equations would be x plus 1 equals 2 or x plus 1 equals negative 2. And you do need to split it into 2 different equations because you're going to get 2 different answers. So in doing this, I subtract 1 from both sides. I have x equals 1. On this side, when I subtract 1, I get x equals negative 3. So there are my 2 answers. Absolute value equations will usually have 2 answers. There are some times when they'll have no solution, like the problem above. So solve each equation, check your answer. If I plug 1 in here, I've got 5 minus 2 times 1 plus 1 equals 1. Well, the absolute value of that is the absolute value of 2, okay, which is 2. Negative 2 times 2 is negative 4. 5 minus 4 is 1. Same thing happens when I plug in the negative 3. Negative 3 plus 1 is negative 2. What's the absolute value of negative 2? 2. Negative 2 times negative 2, again, is negative 4. 5 minus 4 is 1. So I know I solved it right. I do have to check both answers, though. Any questions on that one? All right, so now we're going to look at, where is it? I would like you to try letter H first. Try letter H first. It's at the bottom of the first page of notes. We'll go over that in a second. After you try letter H, or give it at least your best attempt, then do letter G. And just one quick reminder, what operation is between the number and the absolute value if you don't see a sign between them? Multiplication. Good to remember. So try letter H first. I'll be right there, 1 second. First. So taking a look at H first, we have, I'm going to pull this down a little bit. I can't distribute this negative 6 because it's not parentheses, it's an absolute value. So when it's that, I kind of ignore what's inside. I don't care if it's got exponents or square root symbols. I don't care what's inside. You guys might care. It might make you freak out a little bit. But I don't pay attention to that until I've gotten everything else away from the absolute value symbol. So what do I need to get rid of first? Yes? The negative 6 and the negative 12. Which one am I going to get rid of first? The negative 12, because it's subtracted, whereas this one's multiplied. So I'm going to add 12 to both sides, giving me 6 on the right-hand side and leaving me with negative 6 times the absolute value of 3x plus 1/2. I don't really care about that, though, other than to copy it down. So now I have negative 6 times this thing equals 6. So what am I going to do? Divide by negative 6. Absolute value of 3x plus 1/2, again, don't worry about what's inside yet, equals negative 1. Now I do worry a little bit. Why do I worry? Because the absolute value always has to be positive. And is it? No. So this is no solution. Now, again, I have people who, if they saw this -6, I had some people in my other hour who said, oh, it's -6, there's no solution. I said, well, how do you know? They said, because it's negative. Well, they don't know until they've done the other operations that the absolute value turned out to be negative, which isn't possible. Okay? So you have to undo all those other operations first, because if it turns out to be positive, then you can continue solving. Like you did for letter G. Oh, gee, what operations are here? There's two operations on the absolute value. What are they? Adding and multiplication of 5. So we need to undo addition and subtraction first. We're going to undo the addition by the inverse operation, subtracting by 8. This gives us a 5 on the right-hand side, and we have 5 times the absolute value of x minus 3 on the left-hand side. To undo the multiplication of 5, we divide both sides by 5. This gives us the absolute value of x minus 3 equals 1. Any questions so far? So now, to solve this, I need to, because it's positive, I can solve it. How many answers should I get when it's an absolute value equation? 2. Either no solution or 2 solutions. So I'm going to do x minus 3, the absolute, or no, sorry, drop the absolute value symbols. X minus 3 equals 1, or x minus 3 equals -1. Now I add 3 to both sides on the left equation. That gives me x equals 4. Adding 3 to both sides on the right side equation, x equals 2. I have 2 answers. I can plug them in and check. 4 minus 3 is 1. Absolute value of 1 is 1 times 5 is 5. 5 plus 8 is 13. 2 minus 3 is -1. When you do the absolute value, you get 1 times 5 is 5 plus 8 is 13, so it does work. Any questions on solving absolute value equations? We're going to add one little twist to that by dropping the equality, or maybe not dropping the equality, but adding an inequality to it. So we are to solve, and we're supposed to graph. For time's sake, we'll graph a couple, but not all of them for now in the notes, because you guys are pretty self-sufficient at graphing. If possible, write your solution as a single expression. That means if I can write it as an and, if I can combine it, I should. So we're going to start with these. You're like, oh, those aren't so bad. Good thing he's not skipping those. It is good we're not skipping those. Here's why. You know that the absolute value has to always be positive. Now, when I drop the absolute value, though, and start solving, it doesn't matter whether my answer is negative or positive. That's OK. So with this problem, if this were just an equal sign, I'd have x equals 2, right? Or x equals -2. What happens when you multiply an inequality by -1 in the solving process? It flips the symbol. So that's what we have to do here. We're basically saying, hey, here's our answer that x is greater than or equal to 2. Okay? But now we're saying, well, it could have been 2 or it could be -2. We're taking our answer and our value for x, and we are multiplying by a negative. We're putting it on the other side of the number line. So when we do that, we have to flip the inequality symbol. It should be x is less than or equal to -2. And we'll look at the solution for this in just a second to see why it makes sense. But so make a note that when you split into the positive value and the negative value for your equation, because you're going to get 2 answers, you have to flip the sign on the one that's negative. Flip the inequality symbol on the negative. Because in effect, you're multiplying both sides by -1 when you do that. So let's take a look at this. We have, we said 2. That makes sense. 2, the absolute value of 2, 2 is greater than or equal to 2. 3 is greater than or equal to 2. makes sense. If I checked 0, let's say somebody said, well, Mr. Ritter, if I just leave that, it's fine. If I plug 0 in there, right, because 0 would be greater than -2, would 0 be greater than 2 when I put it in there? No. Neither would -1. -3 will, though. Absolute value of -3 is 3, and 3 is greater than or equal to 2. So I know that that is the correct expression, that I am supposed to flip it for the one that's negative. So just be very careful of that. Yes, sir?
Can you scoot the paper over?
Yes, sorry about that. I was trying to zoom in so you could see better. But all right, so now with this one, I'm going to look at this one, and I'm going to go solve. Mr. Ritter, we're going to get some answers today. We can do this. This isn't bad. X minus 3 absolute value is greater than -2. Do I need to worry about flipping my symbol here? Why don't I need to worry about flipping my symbol here? The absolute value can't be negative. Okay? So this one is, we're not going to worry about it. Especially if there was equality there. Now, let's take a look at the next one. Some people said, oh, that's negative. I'm not going to be able to solve it. But you can, because what's my first step going to be? Subtract, not 5, subtract 2. So I've got -5 by the absolute value of x plus 3 is less than or equal to -10. Don't decide whether you can solve it or not until you have the absolute value by itself. We're trying to get this by itself. Divide both sides by -5. And now we get the absolute value of x plus 3 is less than or equal to 2, positive 2. So can I solve this one? Yes. I have a mistake, though. I made a big mistake. What should I have done? Yes. I didn't flip. I divided both sides by a negative, and we've constantly said you got to flip that. So make sure you flip that from dividing both sides by the negative. So our new symbol is actually greater than or equal to 2. And now, still true, we've got an absolute value, and the other side is positive, so we can solve this. We're going to say that either x plus 3 is greater than or equal to 2, just like it says right here, or x plus 3 is what? Less than or equal to -2. So the symbol flipped here because we divided both sides by a negative. We keep this symbol for our positive answer when we go to separate it into two inequalities. And for the negative one, we flip the symbol again. Okay? All right, so subtract 3 from both sides. X is greater than or equal to -1. Or x is less than or equal to -5. We're going to graph this just to see what it looks like. We've got -5 here, -1, here's 0, here's -6. There's my number line. There is equality with both of these, the -1 and the -5. This one says x is greater than or equal to -1, so that goes to the right. They diverge. X is less than or equal to -5. They go in opposite directions. They diverge. All right, I'm going to ask you to try letter D. Try letter D. Letter D right now. If you did letter D correctly, you should get x is greater than or equal to -4, or x is less than or equal to -16. Would anyone like to see that one worked out? A couple people. I'm going to go through it real quick because I do want to make sure that you see how it works. So you guys subtracted 5 first, right? -2 times x plus 10 is less than or equal to -12. You divide both sides by -2. In doing so, this is where some people got a different symbol at the end than I did. In dividing both sides by -2, you had to flip the inequality. you have a positive 6 on the right, and the absolute value of x plus 10 on the left-hand side of the inequality. When you go to separate this, you now have x plus 10 is greater than or equal to 6, just as it was written here, but without the inequality symbol, or without the absolute value symbol. Or x plus 10 is less than or equal to negative 6. When we change the sign on that number, that's when we flip it. Okay. Now the reason we're solving this is because the absolute value was here and we had a positive number here. So now we can subtract 10 from both sides. X is greater than or equal to negative 4. Or, here I can subtract 10 from both sides. X is less than or equal to negative 16. Any, yes? Yes?
Do you have to do it with the negative 6? Or could you do it with x is greater than or equal to negative 4?
I'm not sure. Hold on, what you're asking. So this is, I do have to have both. Less than or equal to negative 16 and greater than or equal to negative 4. So when I drop this absolute value, it creates two equations, in this case, two inequalities. Does that might not answer your question. Hold on. Does that answer your question or no? Okay, it does. Okay. So yes, you do have to do both. Okay. I do want to point out that on the problem above, we're going to change letter B to make that 13 a 33. Make that 13 a 33. When you subtract 33 from both sides, you have the absolute value of x minus 3 is greater than or equal to negative 11. Could it be equal to negative 11? Negative 13, thank you. Negative 13. Could it be equal to negative 13? It can't be equal to that. All right. All right. We're going to look at some story problems real quick. Write an absolute value equation modeling the given situation, then solve the equation. So I'm going to zoom out just a little bit so we can see that on the screen. Yeah, it's hard to see. I'll keep it there so you can see it. Terry's walkie-talkie has a range of 2.5 miles. Ignoring the rest of the thing right now, could I write an inequality for that? What would the variable be? X would be his walkie-talkie. It would be less than or equal to 2.5, right? Because that's like a maximum value. Okay? So right now, if I was just doing this, it would be x is less than or equal to 2.5. But I'm just putting that in the back of my mind, keeping that in mind from some of the easier problems we did yesterday. Terry is traveling on a straight highway, and there's something in there, near mile marker 203. Write and solve an absolute value equation to show the maximum and minimum mile marker that Terry's walkie-talkie will reach, and it should say from marker 203. So here's the idea behind this. I always like to draw a picture. Here's mile marker 203, and here's some person that Terry's chatting with. I don't know why they're there. They're on a walkie-talkie. I don't think they have antennas anymore, but we'll pretend they do. So they're on the walkie-talkie, and Terry's driving by in his car. Car's on a straight path. The problem is we don't know whether he's going, which direction he's going. Is he going this way, toward mile marker 202, or is he going toward mile marker 204? We're not sure. Or maybe he's driving his car in reverse. Probably not a good idea on the highway. Anyhow, this is our base right here. 203 is where it's at. If they could stand right there, they could talk. They don't need the walkie-talkies. But if he's going to reach a certain point where he can't talk anymore, and he's going to reach a certain point this way where he can't talk anymore, and some of you already know what those numbers are, that's great. But we're supposed to be able to set up an inequality. So here's what I write. I write that this is the condition right here. This is a maximum. It's a restraint or a condition right here. Okay? The 203 is what we're aiming for. That's what I'm going to call our baseline. That's what everything's based off is how far away he is from 203. So when I go to write my inequality, I have the absolute value because he could be going in a positive direction or a negative direction. We don't know with respect to mile marker 203. For the walkie-talkie to work, this has to be less than or equal to 2.5 miles, just like we thought in the initial sentence. It says, write and solve an absolute value equation to show the maximum and minimum mile marker. So x is the mile marker, or how many miles, okay? Mile marker. The range of mile markers. We know he could be at 202, we know he could be at 204, and that's okay. The question is, to make this number less than or equal to 2.5, should I do x plus 203, x minus 203, 203 plus x, or 203 minus x? We know it's going to be something like that. Play with those a little bit. Plug some numbers in that make sense. Think about what mile marker he might be near and see if you can decide which one makes more sense. Remember, absolute value is the distance from 0. Absolute value. We're going to label these A, B, C, D, and E. Actually, if you think it's the top one, I'd like you to clap your hands once. Oh, hold on, I meant to say, let's wait and vote. If you think it's this one, you're going to clap your hands once. If you think it's this one, you're going to stick your tongue out. If you think it's this one, you're going to rub your belly. And if you think it's this one, you're going to stomp your feet. Please place your vote now. I had a range of people. All right, so let me pick a number. Let's pick the number 202. If I plug 202 in here, that's going to be 405. Is the absolute value of 405 less than or equal to 2.5? No, it's not. And then same thing here. If I put in, what is it? 202 minus 203, that might work, right? That's probably why a lot of you clapped. We're going to take a look at that in a second. What about 203 plus 202? Not going to work, right? 203 minus x, what's 203? Yeah, that might work. It's based off the baseline. Well, here's the thing. When we do this, we're going to take this expression, we're going to have it less than or equal to 2.5, and we're also going to take it and set it greater than or equal to what? Negative 2.5. See how I have a negative over there? To get the actual mile marker, which expression is going to work out for me? The one that has a negative on the x or the one where x is positive? Let's take a look. Hold on. Let me show you. X minus 203 greater than or equal to negative 2.5. I add 203 to both sides and like, yay, it's positive. Wait a second. That means x, wait. Oh, I think I grabbed the one I wanted. Hold on. No, I didn't. X is greater than or equal to, what is that, 201.5? Which does still work. Okay. I guess either one is going to work. So when I did this, I did 203 minus 8. Yeah, it should be 0.5. 0.5, 201.5. Or, yeah. 205.5, sorry. Oh, no, here's the problem. Look, 205.5, or no, what is it, 201? 200.5, sorry. Now, x minus 203 is less than or equal to 2.5. When I add the 203, that does, you know what? If you said D or B, they both work. So x is less than or equal to 205.5. So that's less than or equal to, I wrote the wrong thing. So we can solve it that way. When I set it up in my earlier classes, we did the baseline minus x. So we did 203 minus x. And so, but they both work. So if you do that, then when you divide by the negative, the inequality flips, you get the same thing. Either way, so watch this. I subtract, I get negative x is less than or equal to negative 201.5. I divide by negative 1. My inequality flips. I have x is greater than or equal to 201.5. And I also have x is less than or equal to 205.5, just like before. Now, is this the only way I can write this? No. For his walkie-talkie to work, he's got to be in range. He's got to be somewhere between mile marker 205.5 and 201.5, but he can't go past either one of those. This is the maximum. This is the minimum for his mile marker for his walkie-talkie to work. All right, let's take a look at, yes, sir.
Can you move the thing to the left?
This way?
Yeah.
Yep. So you would have been okay with this or this. I usually do the baseline minus, and you'll see that in a second as well. A quality inspector at a basketball factory randomly examines basketballs. Any whose weight is more than 2 ounces from 20 ounces are discarded. Write and solve an absolute value equation to find the maximum and minimum weight of the basketball. You guys already know in your head what the maximum and minimum are. We just want to make sure our answer matches up to that, just like the previous problem. So what is the baseline that we're aiming for? What's the ultimate goal? What do you want it to be exactly if you could get it? 20. So this is our baseline. And our margin of error, or our parameters, our conditions, our max-min variation, is 2 ounces. That's over here. So that means when I set up this absolute value inequality, it's got to be less than or equal to 2 ounces. I usually start with my baseline. I say my baseline minus x, but if you did your x minus your baseline, it's still going to work, right? Because we've got absolute value. So if you do 20 minus x or x minus 20, it will work. So now when I do this, I have 20 minus x is less than or equal to 2, or 20 minus x is greater than or equal to negative 2. I'm going to subtract 20 from both sides. This gives me negative x is less than or equal to negative 18. When you divide by negative 1, you get x is greater than or equal to 18. On the other side, when you subtract 20, you get negative x is greater than or equal to negative 22. When you divide by negative 1, you get x is less than or equal to 22. So our final answer for this one, and I'll write it underneath so we can see it, x is less than or equal to 22 ounces and greater than or equal to 18. And we don't have to write ounces if we've written where x equals ounces. Then we're okay, as long as we label what x is standing for. Now, do you think it's easier to use 20 minus x or x minus 20? X minus 20 would actually be easier. Why? I won't have to divide by a negative, so it might be easier to do it that way. Just be aware of that going forward. All right, so give me 1 second. That's it for this.